to our final presentation. This is coursesketch. As you can tell, we're a slightly different group. We're a capstone and not a capstone. We're more part of this thing called Aggie Challenge, multidisciplinary. We'll talk about that a little bit later, but we'll just kind of go down the line and just say our names, I guess, to be easier.
Howdy, I'm Andrew King III, Senior Computer Science major.
Vias Lencia, Senior Computer Science.
Tom Coronado, Senior Computer Science major.
Mariana Owens, I'm a Senior Finance major.
Matthew Dillard, Senior Computer Science major.
Larry Powell,
Senior Computer Science major.
Michael Turner, I'm a sophomore computer engineer. David Turner, senior computer engineer major.
I'm John Soda, I'm a junior computer engineer.
Alright, and our instructors are Dr. Hammond and our TA was Alright, so coursesketch's mission is to deliver an intuitive and as well as interactive learning experience that simplifies instructor and students' interactions. Basically, we want to make it easier for students to work with instructors, instructors to work with their students.
So at its basis level, what is coursesketch? Initially, coursesketch is a massive open online course, or a MOOC management system. This is to say that we make an online course, a website that many students can access in order to submit their assignments or problems via sketch-based recognition. So, if they have a math problem, a discrete mathematics problem, computer science problem, they can actually draw in their answer to be able to complete the assignment. And like I said, use the sketch-based recognition to enable this intuitive interaction. But we also allow the instructors to provide real-time feedback. We're working towards allowing instructors to, from their end, draw on top of student sketches in order to assign grades as well as to provide commentary in order to advance the students through the course in order to say, this component, everything else was right, but maybe this one component of your solution was incorrect, so that they can actually do better for the next assignment. And we also allow instructors to customize their own course content, to create their own assignments as well as the problems associated with those assignments.
So some of the factors that catalyze the creation of coursesketch include the increased use of technology in the education system, as well as problems that have arisen from this, such as with such large class sizes, how do we still provide sufficient individual attention and feedback to students, as well as how can we enhance the education system with technology.
So what sets us apart is that we want to help the instructor be able to do grading, as well as want to give the students a personalized as well as instant feedback to help them understand what kind of issue they have with the problem. As well, we want to support open-ended questions such as sketching or diagram-based questions, and we want to be able to handle a touchscreen environment.
So the development of coursesketch was broken up into 4 teams. We have the instructor team, the student team, a server team, and the sketch recognition team. The instructor and student team dealt with the student and instructor UIs and some of the functionality that both instructor and students are able to use. The server team dealt with communication between all of our servers and some of the server functionality. The sketch recognition team dealt with how the system looks at the sketches and compares it to what the instructor would use for its vision. Currently, we're using it in a discrete mathematics course here at Texas A&M, which is being taught by Dr. Hammond. But we also have it being used in a philosophy class, and we have used it previously for a statics class with trusses. But we also hope to use it for other things in other domains, such as chemistry. For our teams, we have many different people working on it. As we have said, we have a finance major working on it. We also have a math major working on it, as well as computer science and computer engineering majors.
So what are some challenges with it? A couple of challenges: scalability. You have to be able to have quality classes if there's 10 students or 10,000 students. Another one is personalization. Obviously, we all learn differently, and it would be more helpful if these large classes could teach how we want to learn and not how every single person learns. Also, it should be customizable to whatever classes. If I'm taking physics, it should be treated differently than if someone else is taking chemistry, not just multiple choice. Another concern with MOOCs is limited feedback. A lot of them are just multiple choice, fill in the blank, or essay type questions. And really, you don't learn much from that, and the instructor doesn't learn much from you doing those types of questions all the time. There's also some problems with interfaces. For example, I'm sure you guys use eCampus. Each class has a different set, so it can be sometimes hard to navigate items on eCampus. or e-learning was very difficult for instructors to use. So we have to make sure that it's easy to use for students and instructors.
And now for a short demo.
Okay, so here we have a account that's used on coursesketch. It's registered in both the discrete mathematics course and in the philosophy course. So if I were to click on under new course, it opens up all the assignments that are listed underneath that course. And from there I can open up assignment, and from there it shows all the problems that have been assigned to that assignment. And then by clicking on one of those, it opens up the sketch panel. And this is where the students would draw their answer and then submit it to the teacher. So from here we have the question text, and from there that's where the student gets the problem, and then they would do the proof. I'm just going to draw something, and then by submitting it, it should go to the instructor side, where the instructor can then either view it herself or have it checked through the recognition server and be graded.
And some of y'all can't see this right now, but he's actually using Microsoft Surface tablet to do this. So he is using a stylus in order to draw and submit his answers. But you can use a mouse if you were on a standard desktop, or you could even use your finger if you really came down to it and you're using a touch surface.
And so this is kind of what the instructor side looks like. As you can tell, there's these little pencils that they can click on, and when they click on the pencil, it'll actually allow you to edit some course content. Very simple. And then as you can tell, it also has some items on the right that we can also edit. And so this makes it we're trying to make it very intuitive for instructors to obviously be able to edit their course content without going through lots of hoops. And we wanted to make sure that what they see is also what the students see.
Alright, so I was one of the people who worked on the instructor side, and what we wanted to do was make it so that we can have the instructor look at the assignments they've created, create new assignments, and host classes. A big part we worked on this semester was actually having the instructor be able to look at the sketches submitted to her or him by the student that they are teaching. We also had a way of her grading them without the sketch recognition, just going automatically grading all the sketches, because it can also make a mistake with that as going through and mistakenly taking a fraction, let's say, and mistaking it as a subtraction. So we also gave her the ability to grade them herself and change the grade if the sketch recognition got it wrong, or a student wanted to oppose saying, I meant this and this is what I did put, but sketch recognition also said it wrong. We also want so that they can create all their courses and assignments right then and there. They don't have to go in and have a pre-made database with all the problems or some previous made material. They can just go and type up their own problems either from a book or from their own mind, and then display them on coursesketch and have the students do it either in class or at homework.
So what are some of the benefits for students? Well, as you guys saw, the organization of the coursework is really nice. You can see your assignments, you can see your problems, you can go through it really easily. You can do your grades really easily. Students have ability to do multi-domains. They can change the color of the pen, they can change thickness, they can make everything how they want it. Anything you do in pen and paper, you can do pretty much on coursesketch. Along with that, you have recognition from the server that tells you, like if you draw an x-axis and a y-axis right away, it'll recognize it and it'll grade out, for example. Also, if you submit an answer, you get no feedback right away. Is it right? Is it wrong? If it's wrong, what can I do to make it better? So those are some of the benefits.
Alright, so this is a short video that will kind of show a little bit of what the interactions can look like. So this is one from the predecessor to this. This is mechanics. As you can tell, like he said, with the recognition feedback, when you get it right, it shows different items.
This is an example of one of the domains that we did for children, where you draw a circle and you draw a number. and it would just cut up a pizza slice for you in the number that's doing it. Obviously, this is not the interface that we're using, this is not coursesketch, but we just demoed it like this because our recognition isn't perfect yet. And this is just, after that, show you just recognition of someone behind the rows. I know there was no setup for that.
So, I'm Matt, and I work in the sketch recognition domain. We went through, we are using several different layers of sketch recognition. With sketch recognition, you need at least 2 stages. Hypothetically, you need a low-level recognizer, which recognizes, what each individual stroke is. Is this a line? Is this, an arc? Is this a circle? And then you need a high-level recognizer, which recognizes what the shapes together mean. So we're using 2 sketch recognizers, both developed by our very own Dr. Ham. The first low-level recognizer is PaleoSketch, which is a geometric-based sketch recognition software. We're also using a high-level. So here's a little bit about behind how it works. It uses two types of data to figure out what each thing is. The normalized distance between direction extremes. So if there's a sharp change, it can tell exactly which one it is, or it can better tell between strokes, as well as the direction change ratio, which it uses to help differentiate between arcs and lines and things. And is ladder, which is basically a language that you define constraints. You define certain parts that would be in your shape, such as a head for a head arrow. So you have two lines that represent the head, and then another line that represents the body of the arrow. And then you have constraints that would specify, these lines together would be used. And as far as how our recognition server works, it's actually a separate server from the rest of the server architecture. The rest of the servers, we have a lot of servers. Our individual servers only have recognition. That's it. So we'll discuss the servers here in just a sec.
Okay. So I was on the server team, and we had several goals we wanted to get to do. We wanted to be able to send and receive data really quickly, which we figured using Protobot. We also want to remain responsive under stress, maintain communication while the sketch is being done, and tolerate network disconnections, which is all affects particularly close to Daddy. And we also want to do a more effective database storage, which we use Mongo.
So this is the actual server layout. It presents that we have actually one real main server, which is the proxy server, that actually communicates with the client, as well as communicates with all the other servers. As he said, he wants some high-level communications from sending and receiving data, as well as be able to handle under stress. And so what we do is basically we each have one server do one task, and only one task alone. Instead of having multiprocessors or only one computer doing multiple processing, we only have one server per computer performing only one task, which increases efficiency. We have, as he said, the sketch recognition server. All it does is just sketching or recognizing sketches. Then we have the database server as well as the login server. As you know, this login server talks to an actual database as well as the database server talks to one. The reason is because we want to have it safe. If someone hacks into, such as the login server or the database server, we want them separate so no one knows what they're getting as well as no one knows who they're getting it from. Then one is the submission server, which is what the student normally submit. And what it goes through an answer checker server as well as the actual database server, storing and determining what kind of feedback the user will need.
So, as we have mentioned earlier, we are actually implementing this in Dr. Hammond's CSE 222 course right now, which is discrete mathematics. And as far as feedback goes, well, coursesketch is still in its rudimentary stages, so we don't have a formal user study defined for this yet. But the students of the course have been very vocal about their opinions regarding the site and its use. So that is to say that we started off with an initial size of 70 students in the class, actually actively using the site, which is optional, by the way. They can either turn in their assignments by sketching them on the site, or they can turn them in by paper. This this number of 70 is dwindled down to about, last I was told, 20 to 30, students, along with, course drops, few drops, and the like. So that being said, criticism has been, feedback has been mixed, so to speak, just because simply it's very basic right now. It doesn't have all the features, all the affordances that they're looking for in, a sketch-based website, especially in terms of when they have to write out long-winded proofs that would require paragraphs of text rather than, just simple conditional statements. So that being said, a lot of students have actually been helpful in suggesting features for us to implement and that we have actually seen ourselves working on and trying to implement, such as an undo redo button. We actually have this clear function implemented on the sketch so that you don't have to try and redo or worry about having botched an assignment or submission. We also have grade visualization, currently working on that for the instructor side, so that the instructor, once they grade that, a student will be able to on their own view a past sketch and to see what they made on that assignment. A lot of interest was also garnered at IAP as well as the engineering showcase, even at SRW. We presented it all three. This is to say that some instructor side implementations were suggested. If you saw earlier, a fourth panel of our interface was the lecture panel. We're still working on this, but we're trying to get it so that instructors can record their courses or document certain notes that they take and post them by course sketch so students have access to those. Another suggestion made with potential industrial applications. This is to say for the large smart board that you see, actually implementing that to connect course sketch so that as they draw it, we can maybe live cast that or broadcast that via the website. This was something that was recommended to us that we hadn't even considered just because we're just trying to get students to be able to draw and submit things at this point in time. But feedback has been mixed at the very least.
So we've actually had a bunch of challenges, obviously, over the semester. I'd say one of our biggest ones was developing it while it was currently in use. So this is actually the second semester of coursesketch. So it didn't just start from nothing ago. So we actually had some stuff going, like the students could log in, and well, that's actually all they could do on the first day of the class that they had to use it in. So we had to do some really quick iterations to make it so that they could turn in their homework. So that was obviously a really big challenge because while people are using it, you can't break what they're using. You can't lose their data because then, they just got a 0 for homework that they did supposedly. So that was obviously a pretty big problem that we had to face. Another one was developing for scale. As you can tell, we had a large number of servers. Obviously, we could have just put everything on one computer, but because we have to eventually handle and scale everything, we wanted to make sure that we started out with all these different separated servers so that we could just kind of duplicate them and it would just kind of build on itself. Another thing that we have to deal with is long-term programming. So instead of just going for a semester and kind of ending it, we have to design ahead of time to think, how will my statement be used 3 years from now? How will it be used, next semester? And so that's kind of the things we have to deal with. Another, I'd say, challenge would be security. Obviously, we have to protect students' grades. There's laws that require us to protect students' grades. But, so that's obviously a really big deal and a really big challenge that we've had to face with. And definitely affected some of our architecture. So some of our future work, recognition is one. So we have recognition, but we didn't actually incorporate it into the classroom. And that's because it's not perfect yet. I mean, it never will be, but we wanted to meet a certain bar before we have it start affecting what the students actually draw while they draw. Automatic grading, so that's one of our goals. This is one of the long-term goals, is to do it so that the instructor can just draw their solution, the student draws their solution, and it'll grade it automatically. It saves time for instructors, it saves time for students, and it'll hopefully benefit both. Another one is that instructors can create interactive lectures where they could draw their lecture and then halfway through they say, hey student, solve this problem. And if the student gets it correct, then the lecture proceeds in one direction. If they get it incorrect, it proceeds in a different way. So then it's kind of more like a personalized tutor than really a just lecture that you sit down and listen to. Another one is students can take notes and then they can share notes with other students.
I have a couple, but that's one. I heard you guys say that you were developing it while it's in use. Tell me a little bit about how you isolated the testing data so that it's that you would have to test. Well, tell me a little bit how you isolated the test data from production data, and a little bit about your end-to-end testing. Y'all had 4 different groups that were working, correct?
Yeah.
And so how did y'all end up collaborating and making sure that the groups were meeting each other's needs and not just come together magically?
A lot of it's been on like just, progressive, like, we keep going.